Inverse trig functions, they're fucking easy. So the key thing to remember with these is you just have to drill them into your brain. So let's take a look. If you have an integral that is either directly in this form or can be algebraically manipulated to be in this form, you know what the answer is. You know what the integral of that is. So here we have the integral of du over root a squared minus u squared is arc sine u over a plus c. The integral of du over a squared plus u squared equals 1 over a arctan u over a plus c. And the integral of du over u times root u squared minus a squared equals 1 over a arc secant absolute value of u over a plus c. Now, I know that's a lot and it all sounds confusing. You need to memorize these. Like, trust me, you have to memorize them. Let's do an example and it'll start to make more sense. All right, so we have the integral of 1 over root 9 minus x squared. So let's look up here. This is gonna fit into arc sine. What's our a in this function? Well, we need a squared. So we can rewrite this as 1 over root 3 squared minus x squared. Now, let's look back up here at arc sine again. U is always gonna be a function, something x to the something times x, and then a is gonna be a constant. So we come back here, we see that we have the integral of 1 over 3 squared minus x squared. Well, we'll set u equal to x, making du equal to 1. So now we have it in the original function format that we need. Du over root 3 squared minus x squared. And as we saw, this is gonna equal arc sine of u x over a 3 plus c. And before you fucking comment, okay, dx, yeah, I know, I forgot. All my tests at the very end, I go back, write my plus c's and my dx's. I always forget that shit. Don't forget that shit.
So what is arc sine?
Arc sine is just sine to the -1. It's the inverse of sine. So the whole point of this whole thing is, if you see an integral like this and you think, how the fuck do I integrate that? You go, oh shit, it's one of those inverse trig functions. I gotta make it look like this so I can just say that it's this. That's what we're doing. All right, let's take a look at this one now. We have the integral of 1 over x times root 4x squared minus 1 dx. Now, let's look at our 3 inverse trig functions. Try and decide for yourself which one are we gonna use. Arc secant. So, as you'll notice though, it doesn't exactly fit the arc secant mold. We're gonna have to algebraically manipulate this a little bit to make it look like this. So, as you can see, our u value is gonna have to be 2x because u squared needs to equal this. So if u equals 2x, that's not gonna work, right? Because we don't have u out here, we only have x. So we're gonna do one of those things that your teacher does in class and you think, how the fuck was I supposed to know to do that? We're gonna multiply this by 1. So if we do the top by 2 and the bottom by 2, we can rewrite this as 2 over 2x times root 4x squared minus 1 dx. Then we can pop that 2 out and just say dx over 2x times root 4x squared minus 1. So now that we have it in our proper format, we're going to set our u equal to 2x, which makes our a value equal to just 1. But what's our du going to be? Our du is going to be just 2 dx, making dx equal du over 2. So as you can see, if dx equals du over 2, we have, if this is du over 2, there's a 1/2 that we can pull out here once we start rewriting this. So we'll have 2 over 2 times the integral of du over u root u squared minus a squared. We plug in the information that we have. So this is equal to the integral of du over u 2x times root 4x squared minus 1. So that's it. You have it in the perfect arc secant format that you wanted. Your u is 2x, your u squared is 4x squared, your a is 1, so a squared is still 1, and you just plug in, you just plug it in. So the answer here is arc secant, absolute value of u, which is 2x, over a, which is 1, plus c.
Why did you have to make it 2x?
Are you fucking dumb? Are you fucking dumb? No. You know what a better way to look at this is? This is equal to 1 over x times the square root of 2x squared minus 1 squared. So now if you look back at this original formula here, we have u times u squared. We have our u is 2x, but we don't have the 2x on the outside here.
Oh, you gotta bring up the 2.
You feel me? You feel me? Okay, let's do another one. The integral of 12 over 1 plus 9x squared. So look at our inverse trig function formulas and we see that the only one with a plus sign is arctan, so it's gotta be this one. So as with our normal integrals, let's pull out this 12 here. So this is equal to, oh shit, dx. Okay, so let's pull out 12. And we have the integral of 1 over 1 plus 9x squared. And this is gonna be equal to 12 times the integral of 1 over 1 squared plus 3x squared.
dx.
Fuck, dx. Thank you, you're right. So we need our u, so our u is gonna be equal to 3x, and our du is gonna be equal to 3, which means we're gonna have to pull out a 1/3 here. So, shit, that's dx. So we're gonna pull out a 1/3. So we have 12 over 3 times the integral of du over 1 plus 3x squared. And that's perfectly in our formula. So now, if you look here, if you look here, we have du over a squared, 1 squared, plus u squared, we have 3x squared, and we can just plug these numbers right into here. And I would just like to say that I know it's not right to have du on top and x values in the bottom. I'm just doing it to show you where we're getting them from. So this is gonna be equal to, we have a 4 on the outside. So it'll be 4 times, then we have 1 over a. A is 1, so 4 times 1 over 1 arctangent of u. What was our u? It was 3x. So 3x over our a, which was 1, plus c. And then we can just simplify that a little bit without the 1 over 1. Say 4 arctan 3x plus c. How do you feel about this subject now?
I learned so much.
You did?
Yeah. That's what I'm saying, man. That's what I'm saying.
Yeah. Thanks for watching. Make sure to subscribe. If you know my BFF personally, tell her I'm single. And that's it. All right. Oh, and don't forget, if you don't do your calc homework, you're gonna be a failure and you'll probably be a stripper. So.